Hi, I'm Eli. This is the statics problem. It is this log mover. And the question we're asking is, what is the coefficient of static friction between the log D and the member BF? BF is right there, and it is part of the larger member AFBE. The equation we're going to use to find the coefficient of static friction is static friction equals the force normal times the coefficient of static friction. So we're going to be looking for the force normal. A bit more information before we keep going. The contraption rotates about point A. A, C, and B are smooth pins. F and G are welded, and D is a rough surface. So if I get this out of the way. D is a rough surface. A, B, and C are all smooth pins, and F and G are welded. We don't have to worry about what E is because it's not connected to anything. So to start off, what we're going to want to find is this force here, which is the force normal at D. And to start chipping away at that, we're probably going to want to know the weight of this whole thing. So to find the weight, we can just take the sum of moments about A, which is going to be equal to our 800 Newton applied force times 10 meters for its perpendicular distance. It's probably not actually meters, but I didn't make this to scale. And then our weight force, which is going to be negative by convention. And it's got a 4 meter perpendicular distance, because if we look at this circle here, we can see that diameter is 4, so we're going to add 2 for this little beam there, which is this guy, and then another 2 for this distance here, which is just the radius of the log, which is 2 again, so 4, and that's going to be 8,000 over 4, which equals 2,000, so our weight is equal to 2,000. All right. And we are looking at a frame here, so we are going to want to use the method of members to analyze this frame. So to start with that, let's decide on our first member. I think it should be the log itself, because we can tell one of the reaction forces is the force we're looking for. So let's draw those in. Our force upwards is going to be the force of static friction, and this is going to be the force normal. This is point C, this is point D, and then we're going to have reaction forces at C equal to Cy and Cx. And we are also going to have our weight force, which is equal to 2,000. All right, so if we take the sum of moments about C, we can find our force of static friction, which is one of our 3 components to our equation. So we probably want to find that. Let's go ahead and take the sum of moments about C, which is going to be 2,000 times 2. That's moving counterclockwise, so we'll call it positive, and that's just from the weight. And then we are going to subtract the clockwise force, which is the force of static friction, which is going to be 4 for the whole diameter, and then just times Fs. So that's going to be 4,000 over 4, which equals 1,000. So we can say that the force of static friction equals 1,000. Unfortunately, we have a 2-force member here, and we don't know either of the forces, so we are not going to be able to find the force normal from just this one member analysis. So let's work backwards here. The next thing we can analyze is this hook-looking piece. This hook-looking piece, which has points B, G, and C. B, G, and C. And I'm going to guess we'll have to work all the way back to AFBE. I'm not going to guess. I've done this before. But, you know. Okay, we have one shared point. We have the point C. So let's draw in our forces there and make sure to reverse the direction so that we keep things conservative. And we're just going to assume the direction of B for now. So it's probably going to be like that. It's probably not going to be like that, because I got the direction of C wrong. Okay, we got CX, CY, and BX and BY. Okay. So we can find out BX and BY from this, but why would we want to do that? Let's take a look at our next member. This is member which member is this? Oh, it's member AFDBE. AFDBE. All right. Okay, so since we've already established a convention for the direction of forces on B, let's go ahead and make sure we're reversing those for our next member. So we have BX and BY. And then we also have our normal force, the force normal here from D, which is just the rough surface pushing on point D. And since we're accounting for friction at point D, we are going to have to add a frictional force, which is going to be downwards because we already have a convention for that guy. And in fact, we're going to have to reverse the direction of the frictional force too. Sorry, the normal force. This is the frictional force, the force of static friction. There are no forces on F, and then there is a 800 Newton force going directly left on E. And then it looks like this guy gives us a formula for Fn if we just take the sum of moments about A. And since we're taking sum of moments about A, we don't have to worry about the reaction forces at A, so let's write that out. The sum of moments about A is going to be equal to 10 times 800 for that big counterclockwise force on top, and then it's going to be minus, let's remember that this whole thing is 10. This is 6 right here, and then these both are 2 because FB bisects our circle. So we're just going to use either half of the radius to build that. And then, okay, sum of forces about B. Let's subtract, don't want it to be white, dx times 4, and subtract by times 2. And then our force normal is going to be acting counterclockwise, so let's add it. We're just going to call force normal dx because it's acting at point D. Dx times 2, and then the y component is going to be acting clockwise, so we'll call that dy instead of the force of static friction. And 2 times dy. Okay, so we're looking for this guy right here, and we already know dy because it's equal to fs, which is 1,000. So 2 times 1,000, this is 2,000. And let's combine terms there to make it 6,000 over here, minus 4bx minus 2by plus, let's not say plus, let's just say equals negative dx, and let's divide everything by 2 just to get dx on its own. All right, and dx equals our force normal for our equation. So, okay, this equation here is going to give us our force normal to finish out the equation. But we're going to have to follow it back through the members in order to find bx and by. And we're just going to find bx and by by, it looks like, taking the moments about b here. Yeah, take the moments about b. Because we still don't know cx equals 4 times cy, and that's me negative, plus 2, 2 times cx, and then we know cy equals, oh wait, no, guess I never found cy. All right. We're going to take the sum of forces about our first member. Okay, so 1,000 for the force of static friction minus 2,000 for the weight plus cy, and anybody could tell you that's 1,000 equals cy. All right, cy equals 1,000. Awesome. So 4,000 over 2 equals cx. All right, cx is 2,000, cy is 1,000. This is made of two force members, so we immediately know bx and by. So by equals 1,000 and bx equals 2,000. Yeah. All right. And then we are going to plug these into our equation here to find, it doesn't equal dx over 2, it just equals dx. To find that guy. All right. So 6,000 minus 4 times bx minus 8,000 minus 2 times by, which is just 2,000, which is going to be negative 4,000 divided by 2 equals 2,000. All right, and then we have dx, and from earlier we said that dx equals the force normal. So let's finish out our equation, because we just found this guy. Our force of static friction, we said, was 1,000 newtons. So 1,000 equals 4,000. Wait, did I say 4 or 2,000? 2,000. Sorry. 2,000 times the coefficient of static friction. So that's 1,000 over 2,000, which just equals 1/2. So it turns out the coefficient of static friction between those two is, what am I doing? Is just 1/2. Sweet. That's it.